My name is Michael. So today we are going to do a walkthrough over encoding categorical variables labs. So for the labs in overview, in this lab, you will encode categorical variables. You will use the automobile dataset from the UC Irvine machine learning repository. This dataset works well because it contains many categorical features. The objective of this lab is after completing this lab, you will be able to encode ordinal categorical data, encode non-ordinal categorical data. So first thing first, accessing a notebook instance in Amazon SageMaker. So in this task, you will open your Jupyter Lab environment and switch to the notebook to complete the lab. To open the Jupyter Lab on the AWS Management Console, go to the Service menu and choose Amazon SageMaker. Then from the navigation menu on the left, expand the notebook section and choose the notebook instance. And then from there, we look for the notebook instance with the name my notebook. Open the Jupyter Lab notebook instance by going to the end of the row and choosing Open Jupyter Lab. So I already opened this earlier. So now this is our Jupyter Lab after we click Open Jupyter Lab right here on my notebook instance. So opening a notebook in your notebook instance. In this task, you will open the notebook for this lab in your Jupyter Lab environment. Go to the 5 browser in the left pane and locate the 3-3 machine learning dot jpynb5. Okay, 3.3 machine learning 3.3-3 machine learning 5 in notebook. Three machine learning look like it's this. Let's see. Okay, where is it? So in the Jupyter Lab environment, go to the 5 browser on the left pane. 5 browser. This one. Just tab content. Nothing here. Doesn't have anything in that one. Nothing here. Okay, 5 browser. 5 browser. This is a 5 browser. We got to use English. Okay, it's in here. Awesome. And open this English US 3-3 machine learning .jpynb5 by choosing it. If a window appears asking you to select a kernel, select a conda then underscore Python 3 and then choose select. Okay. Follow the instruction in the notebook conclusion. Now you have successful. Okay. Let's follow the notebook. So this is lab 3.3, still in the notebook overview. This lab does not continue the healthcare provider scenario. Instead, you will work with the data from an automobile dataset. In this lab, you will encode ordinal categorical data, encode non-ordinal non-ordinal categorical data. About this dataset consists of three types of entities. The specification of an automobile in terms of various characteristics is assigned insurance risk rating. It's normalized losses in use in compared to other cars. The second rating corresponds to the degree in which the automobile is riskier than its price indicates. Cars are initially assigned a risk factor symbol that associated with its price. Then, if it's riskier or less risky, this symbol is adjusted by moving it up or down the scale. Actuarians call this process symboling. A value of +3 indicates that this car is risky. The value of -3 indicates the car is possibly safe. The third factor is the relative average loss payment per insured vehicle year. This value is normalized for all cars within a particular size classification: two-door small, station wagons, sports or specialty, and others. It represents the average loss per car per year. Note that several attributes in the database could be used as a class attribute. So here we have the attributes information. The attributes including attribute range. Here we have a list of them right here. We can go through them simply from -3, -2, -1, 0, 1, 2, 3. Normalized losses continuous from 65 to 256. Fuel type is diesel and gas. Aspiration SD turbo. Number of doors 4 or 2. Body style hardtop, wagon, sedan, hatchback, convertible. Drive wheels for 4WD, FWD, RWD. Engine location front rear. Wheelbase continuous from 86.6 120.9. Length continuous from 1.1 to 208.1. Width continuous from 60.3 to 72.3. Height continuous from 47.8 to 59.8. Curb weight continuous from 1,488 to 4,066. Engine types DOHC, DOHCV, I, OHC, OHCF, OHCV. Rotor. Number of cylinder 8, 5, 4, 6, 3, 12, 2. Engine size continuous from 61 to 326. Fuel system 1 BBL, 2 BBL, 4 BBL, IDI, MFI, MPFI, SPDI, SPFI. Bore continuous from 2.54 to 3.94. Stroke continuous from 2.07 to 4.17. Compression ratio continuous from 7 to 23. Horsepower continuous from 48 to 288. Peak RPM continuous from 4150 to 6600. City MPG continuous from 13 to 49. Highway MPG continuous from 16 to 54. Price continuous from 5,118 to 45,400. Dataset attribute. This data set was obtained from Dua D and Graph C 2019, UCI Machine Learning Repository, Irvine CA, University of California, School of Information and Computer Science. Step 1 is to import and exploring the data. You will start by examining the data in the dataset to get the most out of this lab. Read the instruction and code before you run the cells. Take time to experiment. So start by importing the pandas package and setting some default display options. So we have import pandas as PD, PD.set options, display max row to 500, PD.set option, display max column to 500, PD set option, display width to 1000. Next, load the dataset into pandas data frame. The data doesn't contain a header, so you will define those column names in a variable that's named columns names to the attributes listed in the data description to URL assigned to let's see what happened here. See what we need to do. Do we have a command terminal in here? Launcher, maybe terminal. Yes, open a terminal here. So copy this, run it here. Nothing happened. So let's see. Okay. So next, load the dataset into pandas data frame. The data is a container header, so you will be define those column name in the variable that's name code name to attribute listed in the dataset. See how to okay. So the data is a container header, so you will define those column names in a variable that's name code name to the attribute listed in the dataset description. You have URL to this import 85 CSV to the code name here in this array. Then we have a df call assigned to pd read CSV with the URL step name and a values header none. So first, to see the number of rows, instance, and columns features, you will use shape df underscore call dot shape. Next, examine the data by using the head method. So df underscore call dot head passing in 5. There are 25 columns. Some of the columns have numerical values, but many of them contain text to display information about the column user info method. So df underscore call.info to display the information about the column. And then to make it easier to view the dataset when you start encoding, drop the column that you want to use. So df underscore call dot columns, df underscore call is set to df underscore call, passing in an array of array is aspiration, number of doors, drive wheels, number of cylinder. Apply the copy method. You now have 4 columns. These columns are contained text values, the df underscore call dot head. The most machine learning algorithms require input that are numerical values. The number of cylinder and number of doors features have an ordinal values. You could convert the values of these features into their numerical counterpart. However, aspiration and drive wheel don't have an ordinal values. These features must be converted differently. You explore the ordinal features first. Now, step 2 is encoding ordinal features. In this step, you will use a mapper function to convert the ordinal feature into order numerical values. Starts by getting the new column type from the data frame. So df underscore call.info. First, determine what values the ordinal columns contain. Start with the number of doors features. You can use value does underscore count to discover the values. So I'm going to save this, make a screenshot to save this value right here. Next, first determine what value the ordinal columns starting with the nums of doors features. You can use the value underscore count to discover the values. This feature only has 2 values, 4 and 2, so you can create a simple mapper that contains the dictionary. Then here we have the door mapper. You can then use the replace method from the pandas to generate a new numerical column based on the number of door columns. So df underscore the car pass in the doors assigned to df underscore car, pass in number of doors dot replace the door mapper. When you display the data frame, you will see the new column on the right. It contains a numerical presentation of the number of doors. Right here. Repeat the process with the number of cylinder column. First get the value. We have df call number of cylinder dot value count. Next, we go to create the mapper right here. We have the cylinder with mapper with this object. Apply the mapper by using the replace method df underscore, pass in cylinder, assigned to df underscore call number of cylinder dot replace the cylinder mapper. And then df underscore dot head. Now we have a new table. For more information about replace method, we can check out here in the pandas documentation. Step 3 is encoding non-ordinal categorical data. In this step, you will encode non-ordinal data by using the get underscore dummies method from pandas. The two remaining features are not ordinal. According to the attribute description, the following value are possible: aspiration STD turbo, drive wheels for WD, FWD, or WD. You might think that the correct strategy is to convert these values into numerical values. For example, consider the drive wheels features. You could use the for WD assigned to 1, FWD equal 2, and RWD equal 3. However, FWD isn't less than RWD. These values don't have an order, but you just introduce an order to them by assigning these numerical values. The correct strategy is to convert this value into binary features for each value in the original features. This process is often called one-hot encoding in machine learning or dummying in statistics. Pandas provide a get underscore dummies method which convert the data into binary features. For more information, we can check out the documentation in pandas. According to the attribute description, drive wheel has 3 possible values. So use the get underscore dummies method to add new binary features to the data frame. So we have a df underscore assigned to bd dot get underscore dummies, passing in the df underscore car and column assigned to the array drive wheel. Now df underscore dot head is going to give this value right here. When you examine the dataset, you should see the 3 columns on the right. Drive wheel for WD, drive wheel FWD, drive wheel RWD. The encoding was straightforward. If the values in the drive wheel column is for WD, then a 1 is the value in the drive wheel for WD column. A 0 is the value for the other column that were generated. If the value in the drive wheels column was FWD, then a 1 is the value in the drive wheels FWD columns, and so on. These binary features enable you to express the information in numerical way without implying any order. Examine the final column that you will encode. The data in the aspiration column only has 2 values, STD and turbo. You could encode this column into 2 binary features. However, you could also ignore the STD value and record whether it's turbo or not. To do this, you should still use the get underscore dummies method but specify drop underscore first as true. So df underscore call aspiration dot value underscore count, df underscore call df dot get dummies, df call column to aspiration, drop first to true, then df underscore head. So we can go back to the beginning of this lab and add other column to the dataset, and how would you encode the values of each column. So we can update the code to include some of other features as well if we want to. So let's say if we want to add something new, was it everything here? 25 of them. No. So let's say we want more than aspiration, number of doors, dry wheel, and number of cylinder. What if we want to add field type as well? If we're going to add field type in here as well, we can put it here and run it. Let's see what happened. So we have field type here as well, beside aspiration. Let's see. Okay, awesome. So that's pretty much it for this lab walkthrough. Thank you so much for watching, and I hope you have a good day.